So we are going to talk today about the law of sines. It's a trigonometry topic that you saw last year, and the law of sines is true for any triangle, and it's actually really simple. First, we have to understand how to name a triangle. So if I call the angles A, B, and C, and really I can call them anything I want, but the vertices are usually capital letters, and then the sides are usually lowercase letters, and every side is named by its opposite angle, or every angle is named by its opposite side. So this would be little a and little c and little b. You remember the naming convention? Yeah, they're opposite, exactly. Okay. The law of sines simply says the sine of capital A over little a is equal to the sine of capital B over little b, which is equal to the sine of capital C over little c. And last year we talked about how we know that's the case, and it's a big long proof, and it turned out we found out why that's the case, and then we didn't really care. We just used the formula. Okay. Now, you really only need two of these. You'll never set up the law of sines where you have something equals something equals something. So you either use A's and B's or A's and C's or C's and B's. Does that make sense? You never use all three. So we need to talk about what information can I give you so that you can solve the entire triangle. Okay? And back in your geometry stuff from the past, we have names of triangles like side, 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 angle, side, angle, 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 side, side, angle, side, angle, 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 and angle, side, side is our favorite one. Is that all of them? Yeah, it wasn't, kind of. Actually, we're going to talk about angle, side, side a lot today. So, well, geometry kind of died. So you should have caught little pieces of this over the last 3 years. And if you didn't, it's okay. You'll be fine. So, basically, if I give you 3 parts of a triangle, now there's 6 parts, 3 angles and 3 sides. If I give you 3 parts, can you figure out the other 3? That's basically the question. Well, what 3 parts will I give you? Here are the options. Side, 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 angle, side, angle, 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 side, side, angle, side, angle, 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 and angle, side, side. Now, there are 2 others that are not up there. Side, angle, angle is the same as angle, angle, side. So we don't worry about that. And side, side, angle is the same as angle, side, side. Because if we do angle, side, side, you won't forget it. So it's a pedagogical tool. I did it on purpose. Okay, so we're just going to go through and look at the information and see, is what I am giving you enough to use the law of sines to solve for the other 2 sides? Okay, so let's start with, I want to start with side, angle, side. Okay, when I say side, angle, side, what do I mean? 2 sides and the angle between those 2 sides, right? So let's say C is 10 and angle A is 30 degrees. What other side do I know? B. Okay, now I need to lock this triangle and all of that stuff over there, or we're going to lose it. Okay. All right, so let's say C is 10, and angle A is 30 degrees, and side B is 5. Is that enough to figure out the rest of the triangle? Okay, let's try it. So which two versions of this formula am I going to use? Do you see a problem?
Yeah, I have a problem.
There's a problem. What is it?
There's a side angle sine and an angle sine and what?
Well, so I have to pick either the A or the B or the C. I need two of them. Right. So if I tried to use the A's, the sine of 30 over little a is equal to, and then I have to either choose B or C, the sine of C over 10. Is that going to work? No, why not? I have two variables in one equation. That's a problem. Okay. What if I switch the C's with the B's? I can't because it's not a 90-degree triangle. There's another formula that we'll get to later. So what I'm showing you is side angle side doesn't work for the law of sines. So if you did this and then called this 15, now you know this and this, but you don't know what that is. Yeah, it doesn't end. It's not even half. That's the trouble. You can find out how big this is, but you don't know the rest of it. So there is another formula we learned called the law of cosines, and the law of cosines will let you solve an SAS triangle. So for today, side angle side is out. It doesn't work. Okay? So let's try something else. Let's try side, side, side. 4, 5, and 6. Will that work? No, because I have an A, a B, and a C. So what do I really need? I need like 2 A's and a B, or 2 C's and an A. Right? That's what we're looking for. So I now know SSS doesn't work. Okay? Let's try angle side angle. So let's call this 20 degrees, and we'll call this 110 degrees. And then what side do I know? Little a. How come? It's in between. It's ASA. So let's say this is 18. Now, this is kind of tricky. I need two A's and a B, or 2 A's and a C. I can find big A. So this is 180 minus 130 is 50. Okay? So now, what if I want to know little b? How does the law of sines work? Well, the sine of 50 degrees over 18 is the sine of 20 over little b. Now, I have one fraction equals another fraction, so I cross multiply. And I get b sine of 50 is equal to 18 sine of 20 divided by the sine of 50. Now, what do I expect b to equal? It's going to be less than 18. How come? Ooh, there's no hypotenuse here. Right. The 18 and the 50 correspond, and the 20 and the b correspond. It's got to be quite a bit smaller than 18. Right. So big or little c is going to be really big. Right. Because the wider the angle, the longer the opposite side is going to be. Now, my triangle is terrible, right? But we don't really need to have a triangle that's the right shape. That is exactly right, Corbin. So 18 sine of 20. Make sure you close this parenthesis before you divide by the sine of 50. And your calculator has to be in degrees. So we push equals. Does that seem reasonable? Yes. Now, let's find little c. How would I find little c? Sine 50 over 18 equals, does it matter? It doesn't, but A is actually a little bit easier. How come? Because B is a big long decimal. So I would prefer A, little a, because I don't want to type in all of that stuff for little b. So sine of 50 over 18 is equal to the sine of 110 over c. Cross multiply. C sine 50 equals 18 sine 110 over, and then I divide by the sine of 50. So 18 sine of 110 divided by the sine of 50. What do I expect here? Bigger than 18. Quite a bit bigger? Yeah, because it turns out, yeah, it's not, it doesn't work like you think it does, because in the unit circle, the height of the wall, it grows really fast to begin with, and then really slow at the top. So we're at 110 degrees. So the growth up here at 110, the wall doesn't get very tall there. But between 0 and 50, the wall gets big really fast. So all you can really say is bigger or smaller. It's hard to say a lot bigger or a lot smaller, because the difference from here to here was more than the difference from here to here, which is weird because we're talking about 60-degree difference instead of 30. But that's because in the unit circle, that sine up high, the wall doesn't grow very fast up there. And the cosine is going to be the exact opposite, right? The cosine grows really slowly at 0 degrees, and it grows really fast, or shrinks really fast up here at 90 degrees, because it's the length of the ground. Okay, so we now know that angle side angle works, but there's a trick. If you have angle side angle, you have to find the third angle before you can use the law of sines. Okay, now let's try angle angle side. So 25, 65, oh wait, that would be a right triangle. We don't want to do that. 25 and 75. And then what side would I need to know? B or C. Either one would work. You'd either have angle angle side going clockwise or angle angle side going counterclockwise. So let's call this 28. Okay. What side can I solve for? Little c. So if I want to know little c, I would say the sine of 75 over c is equal to sine of 25 over 28. Right, this answer has to be bigger than 28. Okay, a lot bigger. This one's going to be quite a bit bigger because we're dealing with a small angle and a bigger angle instead of like a medium and a big. But again, it takes a lot of practice to get good at guessing. So we cross multiply. So c sine of 25 is equal to 28 sine of 75. So 28 sine of 75 divided by the sine of 25. And we end up with a side that's a lot bigger. Okay, and from there, if I needed to, I could find both of the a's. Okay, but we're not going to do that. Okay, so we now know this one doesn't work and this one doesn't work, both of these do work, what about angle, angle, angle? It's not going to work because you need a side to know how big the triangle is. Right? If I told you 30, 60, 90, there are an infinite number of triangles that fit that definition. Right? You need at least one side. So angle, angle, angle doesn't work. Okay. Angle, side, side is the problem child. Okay? When you talk about triangle congruence, does this triangle equal this triangle? Whenever you ran into angle, side, side, you were taught that the answer is no. And that's not totally true. The answer is maybe. Okay? Angle, side, side causes problems because sometimes it works, sometimes it doesn't work, and sometimes it works twice. I'll show you. All right. So when I teach angle, angle, side, I draw the same picture every time. Okay? So angle, angle, side, let's say I had this length, and from that length I have a vertex and an angle. So let's say 38 degrees. Okay? So that could be my A. So I need angle, and then I need a side. So let's call this little c is 10. And then I need another side. Well, no, not really. So my third side is going to be called little a, right? What if little a equals 1? Do you see a problem there? What's wrong with little a equaling 1? It can't equal 1. Why not? Right. If little a is 1, there's no triangle. Right? Now, this angle right here is not decided, which means this side can swivel. That was a bad circle. It can swivel anywhere around that circle. But no matter how you build it, it's not long enough to make a triangle. Or, right, one of the pieces of information is wrong. Either the angle's too big, or C is too big, or A is too small. And you can't really say which is which, but one of those is broken. Okay? What if I make A really long? Let's say I make A 25. Will that work? So it's going to be 2.5 times this, which means it's going to hit way over there. Okay, so if A is really, really short, and instead of saying A, I'm going to say the second side, right? Because we have angle, side, side. If the second side is really, really short, you don't have a triangle. If the second side is really, really long, you always have a triangle. Okay, but what happens as I make that second side shorter? So watch this. And again, this angle right here can be anything. We don't know what it is, so that side can swivel. If I make it 24, do I still have a triangle? Yes. 23, 22, 20. What happens when I get around 10? We're getting closer and closer to straight up and down. Okay? And when I get to straight up and down, what if I make it smaller than that? Then it's not a triangle. Okay, does everybody understand that? So there's kind of this zone where if A is really long, you're fine. Or sorry, A, the second side. If that second side starts to get shorter and shorter and shorter and shorter, eventually it's going to be straight up and down. And once you go past straight up and down, you don't have a triangle. But there's this magic zone in there somewhere, which is like these. couldn't I flip this over here and still have a triangle? Right? I have this triangle here. Okay? Angle, side, side. And I have, oops, I missed. And I have this triangle, which uses the exact same definition. So it's something like 38, 38, 10, 10, and then that might be like 12 and 12. Do you see the problem? Okay, when does that happen? Well, it happens when the second side is just the right length. Long enough to create a triangle, but not long enough to guarantee one triangle. So I built the Geometry Sketchpad diagram. Let me pull it up and show you kind of a physical moving version of this, if I still have it. Okay. Secondary 3, sines and cosines, ambiguous case. All right. So here's my angle. Right now the angle is 28.92 degrees. And then this length right here is defined as 4.59. Actually, I'm gonna make it smaller. Okay. So right now, if I connect this to this, that second side is too short. Agreed? It's not making a triangle. So now I'm going to make it longer, and now I can connect and I have a triangle. But as I shrink it down, now I have two triangles. See that? The circle hits twice, and then eventually it misses. So that's 0 triangles, 2 triangles, and then 1 triangle. How do I know when there is only 1 triangle? Okay, so don't use it. If the second side is bigger than the first side. Okay, so if I call this, this is side A. Oh, I have to actually, let's do, oh, I am a failure face. And then over here we have second side. Okay, so simply put, if the second side is longer than the first side, then you have 1 triangle every time. Okay? And then if the second side is smaller than the first side, you could have 2 unless it's too small, and then you have none. Okay? Does everybody understand the picture? Now, we need to be able to do this in every orientation, but if you understand this diagram, then you can sort of extrapolate your other diagrams and create what you need to. So once again, if the second side is longer than the first side, you have a triangle. If the second side is shorter than the first side, you either have 2 or none, or there is a really weird case, like right there, where you have 1. But that ends up being a 90-degree angle, and it turns out those are really easy to see anyway. So you either have 1 because the second side is really long, or 2 because it's somewhere in the middle, or none because that second side is too small. Okay? So how do we tell? Well, let's work a couple examples, and then we'll see. Let's do one that we know has one side, or sorry, one triangle. So this will say 60 degrees and 5. What could I put over here to guarantee that it has one triangle? 10, anything bigger than 6 or than 5. So 10. So I would say the sine of 60 divided by 10 is equal to sine of whatever this is, b, over 5. Okay? I could cross multiply here, but actually there's a really easy way to solve this. Just times by 5. Right? If I multiply by 5, then that goes away. 5 sine of 60 over 10. So 5 sine of 60 divided by 10. And I end up with, oh, so, no, we're just not done. So I have 0.433 equals the sine of b. Now I just unsign, which is called the inverse. So the second sine inverse of the answer, and that's where my angle comes from, 25.6. Does that angle seem reasonable? Yes, because 10 is bigger than 5 and 60 is bigger than 25. Right? So I ended up with 25.6 degrees. And then if it wanted me to, I could find the other two sides. Okay? Let's do one that can't possibly work. So let's call this 40 degrees, and we'll call this 12. What could I pick for that second side that cannot work? Not necessarily. If it was 11, it probably hits twice. So something really small. 1 or 2. So let's put a 1. Okay? The sine of 40 over 1 is equal to sine of whatever angle this would be, even though it doesn't exist, b, over 12. Okay? Well, no. we're gonna hit a snag here in a second. So 12 sine of 40 over 1. 12 sine of 40 divided by 1. Right, I cannot invert a sine of 7.7. Why not? Sine has to be between -1 and 1. It's basically saying O is 7.7 and H is 1. So the sine of theta equals 7.7 over 1. Can the opposite be 7.7 and H be 1? No. So if I tried to invert this, inverse sine of the answer, I end up with error. Right. Well, same thing. In the unit circle, the height of the wall cannot be 7. The height of the wall is 1 or smaller. Okay? So that's pretty obvious. I did the 12 sine of 40 over 1. I got an answer bigger than 1, which means that triangle doesn't exist. Okay? What about something in the middle? Okay, this is the hard part. What number do you think we could put where we will end up with two triangles? 10. It's got to be smaller than 12, but not so small that it doesn't exist. So we have to pick a length that's long enough to connect, because if we do one that's too short, we won't have a triangle. So let's try 10 and see if it works. So we'll call this side 10. Okay? And these are the hard ones. If the second side is bigger, then you just go ahead and solve it. If the second side is too short, when you try to solve it, you're going to get an error. But if it's in the middle, then you have to do a lot of thinking. So the sine of 40 over 10 is equal to the sine of b over 12. So I bring the 12 over here. 12 sine of 40. I did. 12 sine of 40 divided by 10. Okay, what does that tell me? That there are 2. Okay, how do I know there are 2? Well, I know that a triangle exists because this is less than 1. But how do I know there are 2 triangles? Go back to the original thing we thought about. 10 is smaller than 12. Okay, so here are the questions. So we have a triangle. So we have a whole bunch of triangles, and we ask this question. Is the second bigger or is the second smaller? If the second side is bigger, what does that tell us? 1 triangle.
Oh, we know it's smaller because it's because we know it's 2 because it's smaller, but it's not.
Right. So if the second side is smaller, then we have 2 options. We have 2 triangles or no triangles. How do I know there are 2? The sine of theta is less than 1. Right? How do I know there's no triangle? Sine of theta is bigger than 1. What if it equals 1? Then it's a 90-degree triangle, and you end up with 1 triangle. But that doesn't really happen. And if it does, it doesn't matter, because when you try to solve it, you'll find out that you end up with 2 triangles that are exactly the same. So we don't really need to worry about it. So those are the 3 options. You look at your triangle, and you look at the second side. If the second side is bigger, 1 answer, go ahead, solve it. If the second side is smaller, then either you have 2 or none. And all you have to do is solve it, and if sine is bigger than 1, you have no triangle, and you're done. If you get sine less than 1, then there are 2, and that's the hard part. How do you figure out what the second one is? Because the first one is easy. I invert the sign of the answer, and I get 50 degrees. Okay? Then I go ahead and I find the rest. Okay? Where is the second triangle? That's the part that really confuses people. Where is the second triangle? Well, you have to remember that this angle can pivot. Okay? So what we do is we pivot this over until it hits again. Okay? And I already know how big this angle is. Right? Which means I already know how big this angle is. Right, this is 50, and this is 130, and then you can just solve that triangle. Okay? All right, so I'm going to help you out. The whole first page should be easy. Right, you don't have any angle sides on the whole first page. Okay, turn the page. Let's do 19 first. 19 through 24 is easier than 11 through 18. So, yeah, they all go together. It's a combination of both sides and the angle. So you can't really say the third side is too small. Maybe the angle is too big. Or maybe the second side is too long. All right. So I'm going to draw this triangle. A, B, B, C, and C. And I'll lock this. So all we need to do on 19 is figure out how many triangles are there. So angle C is 63 degrees. Little b is 9, and little c is 12. 1. How do we know? The second side is bigger than the first side. 1. Yes. Angle, side, side. Follow the angle. Angle, side, side. So we are moving in this direction. Angle, side, side. So when we write angle, side, side, if this is bigger, the second side is bigger, then you have one triangle. And it doesn't matter how you draw your picture. Right? You might draw your picture differently and move in a different direction, but the second side is matched up. And Corbin pointed something out. Angle C and side C. That's not how I remember it, but that would work. Okay? If the side that matches the angle is longer, you have one. Okay? It doesn't matter how you draw. As long as A and A match up and B match up and C match up, it won't matter. All right, 20. Angle B, 33. Little a, 27. Little b, 22. Not 1. Everybody agree, not 1. So how do we check to see if it's 0 or 2? So we do the sine of 33 over 22 is equal to the sine of A over 27. Multiply by 27. So 27 sine 33 divided by 22. Wait, I can stop here. I know there are 2 because it worked. And that's why we're doing this section first, because in the other one it asks you to solve. So 22, there are 2. I don't need to figure out what they are. I just need to know there are 2. Okay, 21. 21 says angle B is 29, and side A is 14, and side B is 19. The answer is 1, because the second S is bigger than the first S. Do you get that now, Jimmy? Oh. So I would try to avoid doing the same shape of the triangle every time, because you're going to run into one that's flipped or even inverted. Yeah, and then you're really going to be confused. So here's what you do. Angle, side, side. You follow that direction. Angle, side, side. Yeah, they could be. So Jimmy, watch this. If I said 14, 8, and 9, now we go this way. This one would have 1. Right. It doesn't make sense to go this way because there's no side over there that I know. Okay, so 22 says B is 95, and little b is 24, and A is 5. So they labeled them in a different order, but the picture doesn't change. This is 1. Yeah, so Jimmy, don't follow the order listed in the problem. Draw the triangle and follow that order. Yes. That's not angle side side. Right. So if this was 24, now we have side angle side. So it can't happen, because side angle side doesn't even work. Okay? All right. I'm just going to write one. What if this is 85, 12, and 6? How many does this have? 0 or 2? right? So I write sine of 85 over 6 is equal to the sine of, it's going to be b over 12. So 12 sine 85 over 6. 12 sine 85 divided by 6. And this one has none because it's bigger than 1. Okay. So let's do number 11 together. Okay, number 11. 70, 26, and 25. I'm going to go out on a limb and say this one has 2. Why do we think this one has 2? A is so close to C. It probably has 2. So I set it up. And again, this is number 11. So sine of 70 over 25 is equal to the sine of C over 26. So I multiply this by 26. So 26 sine of 70 divided by 25. Oops, I missed. What does that tell me? There are 2. It is. So, what is angle C? Second sine inverse of the answer. So now I have the sine, 77 degrees.
Wait, so is that what it wants?
Well, it says solve the triangle. All right. So stop what you're doing. What time do we get out of here? 10:45. Okay, I'm not going to be here tomorrow, so you guys can finish this tomorrow. But I just want to make sure you understand what you're doing from here on. Okay? So I now have enough information to finish the triangle. Okay? So finish the triangle. You know how to do that, right? Now, we need to figure out the second triangle. Great. So I have this triangle here, 26, 25, 70 is that angle, and this angle is 77.76. And then you finish it. Okay? Then you draw the second triangle, and that's where the problems come in. So what I do is I swivel this over, and I create this triangle. So that triangle includes this. So this is 26, and this is 25, and this is still 70, but that angle right there is 77.76, so this angle is also 77.76. And then I do 180 minus 77.76, and I get a new angle in here of 102. And that angle will always be obtuse. Okay? Now, I have a triangle where, let me get rid of all this stuff. Now I have 2 angles and 2 sides, and I can finish. Does that make sense? Yes. So you would say like C in the first triangle is 77.71, and little b in the first triangle is, I don't know, B1 and then B1. Okay? And then in the other one, you would say C2 is 102. So you'll have 2 sets of answers, one for the first triangle and one for the second triangle. Okay? All right.